Okay, this is probably going to be review for a lot of you. And grading your quizzes, I saw that some of you solved the problems using a different technique. That's fine. But for those of you that haven't seen this before, I would rather start reviewing for some of you where it's new material than assume that everybody is with me. Okay? At some point in time, we're going to get to a new starting point where everybody's moving forward with no previous knowledge. But, so we're going to go. All right, so my first example is the following. 15x squared plus 45x. By the way, what does GCF stand for, Mia?
Greatest common factor.
Bingo. Okay. You'll also notice that this is not an equation. This is an expression. Expressions we simplify. Equations we solve. We'll get to equations later. Right now we're just simplifying expressions. So what's the greatest common factor? Oh, hold on, I'm jumping the gun here. Let's review some terminology. We've talked already about the coefficient, the variable, and the exponent. Each of these individual things, anybody know what those are called?
Variables?
Nope. They have variables in them, yes, but what's that whole chunk of thing called?
Term.
Nice. These are terms. Okay, so we're going to be looking at polynomials. Polynomials, many, nomials, terms. Many terms, and they're always separated by a positive or a minus. Okay, and you know this, we're just given vocabulary for these things. And what we're going to be doing is we're going to be simplifying expressions and looking at each individual term. So the next question is, what's the GCF between those two terms?
15?
Close.
15x.
Good. 15x. Oops, wrong color. Hold on. Okay, so I'm factoring out a GCF out of both of these. When I take 15x out of 15x squared, I'm left behind with an x. When I take 15x out of 45x, I'm left with a 3. By the way, I'm assuming you all realize that that process of factoring out is actually just division, yes? Do I need to talk about that, or is everybody good to go? Give me a thumbs up if you're good to go, please. Okay, good. And that's it. We can't do anything else with it. There's nothing else to factor. You can't add these terms. You just leave it alone as that. Okay, so we factored out the GCF. That's going to become a fairly common practice, and that's a thing that you want to do at the start of every single problem. There might not be a GCF, but you want to be asking yourself, is there a GCF here? Okay? Problems. All right, next example. Looks very similar, but it's a little different. Factor out the GCF and tell me what you get, please.
$15x parentheses 3x in parentheses.
Close. And that's why I have this in it. Go ahead.
3x plus x.
No. Remember, this is a division. This is okay. Go ahead. Who's talking?
3x plus 1.
Good. Okay, because remember, it's division. So 45x squared divided by 15x is 3x. 15x divided by 15x is 1. There's got to be a term there. Okay. Now, we're not going to do this except for this one particular problem, but you can check this by going in reverse. If I take this times this and this times this, I should end up with that. Well, do I? 15x times 3x, 45x squared. 15x times 1, 15x. Same, we're good to go. Okay? Again, you're not going to do that every problem. It's way too much work. But it is a process there by which you can check to see if your answer is correct. And we're going to use that a little bit in some other problems when we start working through the different types of problems that you'll see when we're working on factoring. Okay, next problem. Whoops. Let's make things a little bit more interesting here and introduce a different variable. Figure out what the GCF is, factor it out, see what you get left, see what is left behind is what I tried to say. Wait, hold on, wait, stop. Give everybody a second. I don't want you to spoil all the fun for others. Is that you talking, Emily?
Yes.
Okay, so we'll come back to you in a second. Give everybody about another 30 seconds. All right, Emily, go.
3x squared y 6y minus 9x and parentheses.
How'd she do?
I thought there could be like a bigger factor.
Ooh.
Like, can't you factor out 9?
Oh. Emily, can we factor out a 9?
Yeah.
Yeah. Okay, so remember, we want the GCF, the greatest common factor. So we actually want this, and this to be 9, 2, and 3. Now, how are you going to recognize that? In a problem, when you're done factoring out the GCF, you want to see, do the terms inside the parentheses have anything in common? And when we did it the first time, you notice that 6 and 9 have a common factor of 3, so we didn't factor out enough. Go back, fix it, good to go. Also notice that when she did factor it, she took out an x and a y and took the highest power that was common between the two things. Okay. So the highest power between the first and second term of the x is 2. The highest power between the y's is 1. Okay. Good. Any problems with that? And you've done this before, right? So this is old hat. Good. All right, let's get a squiggly line in here. Move this up. And talk about your friend and mine. What does that stand for? Please tell me you've done FOIL before. Okay, good.
Outsides, insides, lasts.
Good. All right, now we're going to go backwards. So we started by factoring out a GCF, but with the stuff we're going to do, we also need to be able to FOIL. So if I take something like x plus 2 times x minus 1. Okay. The whole big picture for this lesson is we're going to go backwards and we want to end up with something like this. But we also need to be able to FOIL so that we can check our answers if we have to. I know it's been a while since you've done this probably, but it means first terms multiplied together, outside terms multiplied together, inside terms multiplied together, last terms multiplied together. Therefore, this becomes x squared plus 2x minus x minus 2, which gives me x squared plus x minus 2. And you've done a ton of that. So I don't want to beat a dead horse. I just want to make sure that we're all on the same page. You can do that. We're going to focus mainly on what I call the OI term. And this would be the OI term. Notice it comes from this. OI. O-I. All right, we're going to use that when we're doing what we're doing next. Okay, so what are we doing next? Well, we're going to start factoring. And this is a building process, so we're going to factor and eventually turn these factored problems into equations, but again, it's still just a expression, not an equation. And some of you may have learned a different way to do this. I don't care what technique you want to use. If you want to split the middle term, split the middle term. I personally hate splitting the middle term. I think it's a waste of time and too time consuming. But I'm not going to tell you not to do it, because if it works for you, great. My method might not work for you. Okay, so we want to do something like this. I want to be able to factor that. Okay? So I'll show you how I do it. If you have a different technique, I mean, I've seen everything from something called boxy to splitting the middle term to fishy to all these other wiggity whacked methods. My method is not very algorithmic. It does involve a little bit of guess and check, but I find it a lot easier than everything else. Okay? So remember, in the quadratic formula, or the quadratic form, I should say, not formula, there's an A term, a B term, and a C term. All right, so we're going to start easy, and I know that this is going to break down into two binomials. Remember, these are called binomials, two terms, binomial, by two nomials terms. I know that the first two terms have to be x. Why? Because that's the only way that I can multiply two things together to get x squared. That takes care of the f in the FOIL, I should say. Now the fun part. I need two numbers that when multiplied together give me 6, but when added together give me 5. Okay. And for some of you that have done this a lot and are very good at it, this is an easy process. For those of you that are new or struggle with this, you can do a varying degree of involvement here. For instance, you could list all the factors of 6. 1 and 6, 2 and 3, -1, -6, -2, and -3. And then see which of those work for you. And that is one technique that I've seen people learn. They would come here and they would say, okay, let's see, the factors of 6, as I already mentioned, were 1 and 6, 2 and 3, -1 and -6, and -2 and -3. And then the question is, which of those add up to be 5, and go from there. However, I would imagine that most of you don't need that initially, and you recognize that the two numbers we want are 2 and 3. Therefore, this becomes, this becomes +2, +3, and we're good to go. Okay, now, what does that mean? And what did it mean when I talked about the OI term? Well, this is what I can use to check my OI term. I know that the answer, the 6 is good to go, because I know that 2 times 3 is 6. The OI term comes about from this times that, this times this, and add those up. 3 times x is 3x, 2 times x is 2x, 2x plus 3x equals 5x. Bingo, I'm good to go. As you get better at this, you're not going to need to look at the OI term. You'll be able to do this in a heartbeat. And some of you can probably already do this. So let's see if you can do it with this. Oh, come on, Reedy. Okay, try this one now. Factor that, please. While you're working, notice I said factor, not solve. We cannot figure out what x equals. When you get it, give me an emoji. Let's go emoji, whatever this is, celebration thing. Good. Almost everybody. All right, Danny, what do you got for me?
X plus 3 and x minus 7.
Okay. I'm going to check his work. It's not that I don't trust him. I'm just going to check his work. 3 times negative 20. Sorry, 3 times negative 7 is negative 21. I got that. X times x is x squared. That's the easy stuff. I didn't even need to look at that. I did anyways. Now I'm going to check the OI term. 3 times x is 3x. 3x plus negative 7x is negative 4x. We're good to go. Thank you, Danny. Nice job. Problems, questions, concerns? Okay. Let's ramp it up a little bit then. Let's take a look at one that combines both things that we've talked about. Go. When you get this one, give me the thumbs up emoji, please. Getting there. Good. Mm-hmm. Anya, can you tilt your camera down a little bit? All I can see is your forehead. Oh, there we go. Good, 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 good. Nice. Getting there. Good. Christopher, you seem to be struggling listening to directions. There you go.
Sorry, I clicked the wrong one.
I understand. It happens. It happens. This whole technology has got everybody flustered. Okay, so let's do it again because they disappear. If you have the problem solved, give me the heart emoji, please. So I can see who has it and who doesn't. Good, 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 good. Getting there. Okay. All right. Charlotte, you're up. What do you have to do first?
Well, I actually have a quick question.
Certainly.
So can you pull out any, can you do greatest common factor for this?
Oh, yeah, you can. You have to, in fact, because we don't know how to factor a cubic. By the way, do you know that?
Okay.
Before I continue, is everybody familiar with the term cubic? Yes? Okay, that's a polynomial raised to the third power. We've done quadratics. This is a cubic. Okay, so Charlotte, back to you. So yes, GCF is actually what you need to do. And what is that GCF?
2x.
Okay, and what did that leave behind?
It left x squared minus 7x plus 10.
Good. All right, then what?
I didn't really get that.
Okay, so you got the GCF. You didn't get the further factoring.
No.
Okay. Let's see. Megan, what do you got? Did you get the front? Don't remember who did it and who didn't. Did you get the next step?
I think so.
All right, give it to me.
I got x minus 5
x minus 2.
If she's right, give me the clapping emoji, please. There seems to be some agreement, Megan. Good job. Okay. I'm not sure that she's correct, so I'm going to check it using the OI term again. This OI term checky thing is completely optional, but it will help to make sure. It's easier than multiplying out the whole thing to get back to this. So negative 5x plus negative 2x is in fact negative 7x. Good job, Megan and Charlotte. We're all done. All right, now this last problem illustrates the fact that you need to attack each of these problems by doing a GCF first. If not, it's going to make your life very difficult. And the last thing I would say to you is when you're done, make sure that, whoops, let me put that 2 back in there. Make sure that none of these have a common factor. So you'll recall earlier on when we got to that other problem, we didn't factor out 9, we only factored out a 3. They should have no common factors. Okay? And again, I know you've done this before. Some of you will fly right through this. Some of you might struggle a little bit. It is pretty much a matter of guess and check. If you're a split the term person, if that works for you, use it. If you're a boxy person, if you're a fishy, if you're any one of these other crazy, weird methods that people have taught you, whatever works for you to get down to this point, I am 100% good with. Okay? Questions on any of this? Outstanding.